Hello everyone, in this video let's discuss the SR parser problem in the compiler design. So if we see the theory part, this SR parser will be having two data structures. One will be the stack and another one will be the input buffer. So both will be the columns in my table. Next, it can perform four operations. First is shift, second is reduce, third is accept and fourth is error. So these are the three which we will be using mainly, first, second and third. So we will be rating the possible actions in the actions column. Now if we see the conflicts which may arise in the SR parser, it will be of shift reduce and reduce reduce. So while solving the problem, I will explain what are those two conflicts. Now the input string is given id star id, just copy it here, id star id. Next, at the starting of the problem, my stack will be empty, which will be represented using a dollar symbol. Now, if you see, these are my three producers, which are producing the productions. E is producing two production, which is separated by a column. T is producing two production. F is producing two production. So, since my stack is empty, what I will be doing? I will be doing a shift action. So the first element, that is id, will be shifted towards the stack. So dollar will be same. Next id will come here, and with this input buffer we will be using the dollar symbol, because in the input buffer we will be emptying the elements and we will be shifting them towards the stack. At the end of the input buffer, all the elements will be emptied, only dollar will be left in the input buffer column. Now id is shifted here. The elements left out here is star is left, id is left and dollar is left. Now what I will be doing is, I will be searching for id, that is the first element that I shifted here, in the right hand side of my projections. So right hand side of my projection separately. Yes, id is a separate projection produced by f. So what I can do? I can do a reduce operation. I can do reduce operation, f producing id. So in the place of id, I can place f. So dollar f, here star id and dollar will be left as it is. Next, I will search for the f, capital letter f, in the right hand side of my projection, whether it is a separate projection or not. If you see here, f is a separate projection produced by the capital letter T. So I can reduce it. So reduce T producing capital letter F. So in the place of F, I can use capital letter T. Star id dollar will be same from the previous step, because only these elements are left. Now I will be searching for the capital letter T in the right hand side. So yes, capital letter T is in the right hand side and its producer is capital letter E. But here arises a shift reduce conflict, whether I should shift or I must reduce. If you see the previous scenario, when it is produced a single element in the right hand side as a separate projection, we must reduce it to capital letter E. But this is the first producer. This is the first producer of all the projection. So what you must be doing is, here comes the conflict, that is shift to reduce. Using this, you will not reduce, you will shift. You will shift. Because the first producer you can't reduce. The first producer you can't reduce until my input buffer is empty. Until my input buffer is empty and I am having only dollar which represents the empty, until that time I can't reduce capital letter T to capital letter E. So hope you understood. Now let's move on. So I said I will shift the value. Which I must shift? Multiplication. So dollar T multiplication. I will search for the multiplication in the right hand side, whether it is a separate projection or not. No, there is no separate projection of multiplication. So only left out elements is id and dollar. Since there is no reducing option, so I will shift here. So if I shift, id will be shifted here. Dollar T star id. So only dollar is left. Now my input buffer is empty. so you can use the first producer. So what is this? ID. So ID is a separate projection is right hand side, so you can reduce. So reduce F producing ID. So in the place of ID I will be writing F dollar T star F, only dollar will be left here. Now search for the F in the right hand side whether it is a separate projection. Yes, it is a separate projection. And another scenario is T star F. So T star F is also a separate projection in the right hand side of my all projection. So here arises the reduce conflict, where you can choose this one or this one. So to optimize the solution, I will be choosing the projection which is bigger. So T star F I will be producing. So T star F I will be selecting. So reduce T producing T star F. So in the place of T star F we will be writing capital letter T. Here my input buffer is empty, so I will be writing the dollar. I will search for the capital letter T in the right hand side whether it is a separate projection. Yes, my capital letter T is a separate projection which is produced by capital letter E. Since my input buffer is empty, I can use E. So I will reduce E producing capital letter T. Now since I reduce it E to T, dollar capital letter E will be here. Here dollar will be there. Dollar means input buffer is empty now. Next, since my input buffer is also empty and in the stack I am having my first producer, you can write the action as the accept. So here our problem will be completed. So these three are the main actions which we will be using. So keep it in mind, the shift and reduce, shift reduce and the reduce conflict. So when you will use the shift reduce will be used when my input buffer is not empty. I will be using the shift reduce conflict. When reduce conflict will be there when two or more productions can be reduced. So you will be choosing the bigger production to optimize the solution. So hope you understood the concept of the SR parser problem. If you have any doubt, please comment below. If you liked the video, please subscribe and support us, because your one support motivates us to make more engineering related videos. Thank you.